Okay, hi folks. I'm Anson Garcia with Verizon. I'm from the great state of Texas, and I have with me today what is considered the SDWan expert, Casey Clary. Casey, introduce yourself.
Hi everyone, Casey Clary. Um, like Anthony said, I know a lot about SD-WAN, played with a lot of different vendors, so hopefully we can teach you something.
Awesome. Okay, so we're going to talk about why SD-WAN today. And when we started hearing about this at first, I was like, oh no, Verizon's dead. MPLS is gone. That's not the case. The case he's going to kind of drive that home today. And I'm kind of an old school route switch guy. And basically what we did back in the day and still out there today, I would probably say 80, 90%, maybe Casey can give us some more statistics on that. But there's still a lot of folks that have this mindset and have this architecture where everything's centralized. And what I mean centralized is we have a firewall somewhere, we got big internet pipe, and we have security devices and things like that, internet breakout there, and then we have security policy and all these things that we do, QoS stuff and DSCP and painting and characterization of all these things, and we do them. We create a policy, and then we distribute that into our routers and switches around our data network. So that's historically what we've done in the past. So we're going to be hitting 4 topics today. Number 1, transport and hardware independence. Number 2, path intelligence. So this is where we measure performance of different service providers or different transports and things like that. Traffic steering of applications, kind of the ability to prioritize applications on the network. And then we're going to provide visibility of applications rather than ports and protocols, which we've kind of done before. And now these 4 concepts, you can kind of think of them. And if you're a route switch guy and just learning about SD-WAN or just got introduced to it, we've been thinking about those 4 topics, because you could have talked about those 15 years ago. So what's different? Casey's going to kind of lead us into this topic, and this is just an intro today. So by the way, these 4 topics we're going to have down below in the description, and if you're just interested in 1 or 2 of them, you can just click below in the timeline. It'll take you right to that particular topic. So number 1, transport and hardware independence, and this concept of creating an overlay network. Casey, what the heck is all that about?
Well, I think it's probably best if we just go ahead and jump into our whiteboard session, and maybe we can start talking about, the differences of how we can use these transport and what is this overlay or underlay network that you keep hearing so much about.
I love pictures. That's a great idea. Okay, Casey, here's our whiteboard. Take us through. What do you have here?
Okay, so this is kind of a really basic design for what we typically see in an SD-WAN environment. We have our data center at the top. So we have 2 devices there representing data center 1. And then we have 2 branch sites. So we have BR1 and BR2. So let's first talk about this overlay versus underlay. This is obviously like the physical drawing, right? So if you were to route through BR1, we would see lots of different hops, right, to get to the data center. We'd see, the PE, all the other PIP routers that are in that MPLS cloud, which is okay. And that's what we're going to call our underlay. Now, our overlay is going to be using tunnels. So I'm sure you're familiar with GRE, IPsec tunnels, right?
Yeah. I've been doing those for 20 years.
Right. So we're taking stuff that's already there, and we're going to repurpose it for this like new type of architecture. So we're going to essentially build a tunnel from BR1 to our data center here, and then with this SD-WAN, we can also build a tunnel to our branch site, our branch 2 site as well. So if we were to do like a trace route, or we only see the IP address of BR1 and the data center. We don't see everything involved now. But the nice part is, like, we keep talking about, we can use multiple transports. We can build a tunnel over MPLS, or we can build a tunnel over the INET. So we'll have 2 different paths to get to our destination here.
Okay, so hold on. So traditionally, when we talked about GRE or IPsec tunnels or DMVPN,
right,
way back in the day, we did this way back in the day, and we did it more for security purposes. What's the difference here?
Well, we're still leveraging that security, right? Because when you send your traffic over your MPLS, it's secure. Like this is a dedicated network to you. But we really want to use that internet transport that you might have at some of these smaller branch sites, right? You have PIP, but you also have some broadband circuits. Well, you can't really trust the broadband. People sniff your packets, but if we go ahead and encrypt it and put it over a tunnel, we know that, hey, that packet can only be seen between these two devices.
Okay. So traditionally, we used to have internet and we used to do DMVPN or
right.
GRE or whatever because we had these broadband circuits that were cheap. But we're using it kind of in a different way here, still for security, but transport independence. Drive that home for me here.
Right. So I think the way that we need to think about this is both of these tunnels can be in an active state. So we have active routes here. So although when you used to set up your tunnels, right, you had to put it in your routing table, and that was just your path. But here we have two routes, and we're gonna leverage both of those at the same time. So they're independent of each other, but they're going to be leveraged for this SDWan environment. And that'll be kind of probably a better segue into one of our topics. But just for here, understand that we have tunnels on both, and these are both viable paths. We can load balance, we can prefer one or the other, which, the cool stuff that we're going to talk about in a few minutes.
Yeah, and that was hard to do way back when. I mean, you had to do per path or per TCP connection. There was all kind of weird. You really couldn't do it good. You just kind of shot in the dark with it.
Let me clean up our drawing just a little bit, if you can.
Okay.
So, Anson, do you have a pretty good understanding of the underlay versus the overlay, and why we can use these different?
I know it has something to do with IP routing.
Right.
So, I've kind of got my head around it, but let me see if I can explain it and you draw it out for us. So, as I understand it, the underlay is like Verizon's MPLS network. I mean, BGP stuff and all that stuff we used to do back in yesteryear when we would do what we call a CE router, the customer edge router. We had to go in there and we needed AS numbers and we needed to inject our BGP routes and things like that. And then, as I understand it, correct me if I'm wrong, that CE router is kind of still there, but we're kind of step back from it one hop, let's say, and we're going to put this other device in SDWan,
or
edge device or something like that, and there's going to be this box there, and then that's where we're going to do this GRE tunnel. And now I have an overlay network because I have my IP network that's on the back side of that, on my network, and then I don't really, who cares what BGP, AS, and all this stuff, the MPLS providers, I don't care. I just care about my next hop. Am I explaining that right? Do I have it right in my head?
You're right on the nose. You're right. We used to do BGP right here. That's how we would advertise these routes in the back end, right? And through our MPLS cloud. But we no longer have to do that because, like you mentioned, we're going to just build a tunnel. All this edge device really needs to do is know its next hop, because we're going to let the MPLS cloud take care of the BGP portion for us. That's already set up to do all the routing.
Would that next hop be the CE?
It'll next hop would be the P.
The P. Okay.
Yeah.
Okay.
Yep. And same for like our INET path, right? We're going to just say, hey, just send it out to our ISP. Just here's your next hop. Just let him handle it, because it's publicly routable IP address that's either given from our modem or that we own.
Yeah. So it's the GRE tunnel endpoint that we're going to build over that, and that's the overlay.
Right. And each vendor has its own way of doing their advertisements for the overlay. But once that tunnel is established, they're going to start trading routes.
Okay. So, and the routes being, let me get my pen here. I'm going to use, how about I use, I like purple. So the routes you're talking about, the overlay really is if I have some, I'm just going to put a little circle right over here. Okay. So I like purple, and I think what you're explaining is my overlay, like let's say I have a network over here, 192, whatever, some RFC 1918, and then I have a network over here, and I have a network over here. That's my overlay. That's my network. I don't care what's in the middle. Is that right? Am I representing that right?
That's right.
Okay.
So,
Okay. Good. So
yep,
I just need to worry about my network, not
exactly.
anyone
Not to
else's
worry about
network, not my provider's network.
Nope.
I get it. So hence the transport independence, because it
Correct.
doesn't matter if the iNet is Comcast or Time Warner, and it doesn't matter if this is Verizon or AT&T. My GRE tunnels and things like that can be rebuilt, and my network really doesn't worry about. I'm not ingesting routes that have to do with Verizon or AT&T
Correct.
inside my network. Do I got that right?
You got that right.
Okay, awesome. So interesting. So this means that I can choose any type of transport, MPLS, broadband, LTE, and if
As
I
long as you can
choose to
build a
get,
tunnel over it.
yeah, we can build a tunnel over anything. And if I choose to have degraded service, I can even order AT&T's MPLS. I didn't mean
I don't know why you would, but
that. Yeah. All right. Okay. So anything else on that transport and hardware independence?
I don't know. I think you got it. I think you understand it pretty well now.
Okay. And then hardware independence, I guess it just doesn't matter. Are they coming out with white boxes or some open protocols for these things? Or what is hardware? When they say hardware independence, what does that mean? Or does that just mean the hardware that's in front of me doesn't matter?
So hardware independence means we can start running this on other types of boxes that are not purpose-built boxes. So
Oh,
you're
I see.
familiar with virtualization, right?
Yes.
And VMware is a pretty rock solid product. So we've been setting up firewalls and Cisco CSRs in there for a pretty long time. But what we want to do now is start making a small white box per se, where
On x86. On
well,
x86
what?
platform,
Yeah,
right?
and I've seen people just say it'll run on any type of x86, but there are requirements before we
Oh,
just
okay.
validate it.
Okay. So there's IOPS, there's more to it. There's some
Right.
other stuff
Make
there and maybe some
sure
network card.
CPU memory allocation that we can give the box, because what we're seeing is maybe it's not that white box is just dedicated for SD-WAN. Maybe it's dedicated for SD-WAN and it's supporting a firewall or WAN optimization. You're going to start service training, but honestly, that's a whole nother topic. That's a whole nother
Okay.
video.
Okay. So just in layman's terms, then, when we say transport independence, we understand that that's Verizon or AT&T or internet. It doesn't matter what kind of circuits or who you get those circuits from. And then we say hardware independence is there's some virtualization going on in somewhat of common denominator platform, and that common denominator is virtualization, VMware,
OpenStack.
Zen, whatever, OpenStack, all these other hypervisors that are out there. Okay, but there's certain requirements still within that realm.
Right. Just like when
Okay,
you get Windows 10, right? They have some baseline requirements for you to run that OS on, right? I mean,
got you.
same
Yeah,
concept here.
yeah. Right. Okay. That makes sense. Perfect sense to me. Topic number 2 is path intelligence. And what we put here is measure performance of service providers. So there's some
Right.
concept of measuring this path intelligence. Tell me about that.
Right. So we've already stated that we have our tunnels, right? So we have one tunnel for MPLS, and then we also have another tunnel for iNet, right? The
Okay.
red and yellow.
Okay. So my red
Well,
is a tunnel over the MPLS circuit. Yellow's tunnel over the
uh,
iNet.
yep, correct.
Okay. Got it.
So we don't want to limit ourselves to just using one path or the other. But with SD-WAN, we can actually do some intelligence here and saying, what's this link look like at this time? Each vendor kind of has their own way of doing this, but essentially we can start measuring things for our SLA, like jitter, which I know is super important to you coming from your voice background.
Oh yeah, that's big on our side.
latency.
Big too.
We can do packet loss, which
That's big
it's like
too.
the trifactor right
This is
here.
voice stuff, voice video stuff.
We can even look. I've seen one vendor. He can actually measure the MOS score of the link if a call is going, and then we can look at.
So hold on.
Yeah.
So you're saying we have intelligent paths here, and these two links, red and yellow, I can get the performance statistics or MOS score if we want to be kind of general, and we can look at jitter, latency, packet loss, and things like that. Okay, so let's say we can do that. I know my jitter, latency, packet loss on the red line. I know my jitter, latency, packet loss on my yellow line.
Right.
Okay. So what?
And well, this kind of leads into our third topic here about traffic steering. So you now know these parameters, right? Well, you again have you're strong in voice. If I said we're at 30 milliseconds of jitter, you'd say that's not good, right?
That's not good because we got de-jitter buffers and we got to keep up with those things. Yeah.
Right. So we're constantly measuring on these two links. We're looking for these parameters: jitter, latency, packet loss, and utilization. But let's just say we focus on the top three.
Okay.
So with SD-WAN, we can actually write a rule and say, hey, voice traffic, you're going to always prefer MPLS. And then if we violate, we go to INET. Because we're paying for that PIP circuit, right? You want to use it. It's guaranteed bandwidth. You got guaranteed QoS, from a service provider level, right? So we want to make sure all our voice traffic is guaranteed to get across the path.
Okay, I see where you're going with this. So we have path intelligence in that we know these statistics for every path. And now you're telling me that I can steer voice from one path to the other, even though one is still up and performing well in other things, FTP, Telnet, whatever is going on, whatever data is going on in there. Okay, that's interesting to me. That's something that we haven't been able to do in the past very easily. Okay, so tell me about this path. We have some path intelligence now, and we're going to kind of get into this traffic, steering kind of thing. So are you telling me that I can have, let's say we have 4 calls on this guy right here, and those calls start getting degraded? 1 or 2 of them, we don't know, but there's within those calls, we start getting some jitter, some latency, packet loss beyond our policy, and we'll leave the policy stuff for, for another talk, but we have some policy violations here. What can I do? Can I move all 4 of those calls somehow, magically over here? Now, this link here is still, I don't know, they're doing CRM, they're doing all kind of stuff on MPLS. I just want to take those 4 calls. Can we do that? Can we move from one to the other?
Yeah, we could definitely do that. So let's say, like you said, you have voice, maybe you have FTP, and you have Office 365, and they're all using MPLS right now. Well, they're not truly impacted by high latency, right? Like it might be a little inconvenience to the user, but the voice user is going to notice it. So we have that policy in place where we see an SLA of 30 milliseconds of jitter, we're going to go ahead and move him over to our yellow path going through INET. Now, this will be seamless to you. It's just going to move that flow over. So from your perspective, you didn't even know that this happened.
Okay.
But let's say our jitter went down. Our jitter goes back down on this MPLS path. Like maybe.
Okay, wait. So you're telling me we moved the 4 calls over here, and I'm going to erase them from over here. All right. Okay. They went away from over here. Now you're telling me that somehow you're saying that somehow we're within policy over here on the red line.
Right. Because you bought AT&T, so we don't know what they're doing throughout the day. So some days it's high.
some days it's fine, sometimes not. You never know. So we're same 4 calls are going on.
Yep.
And you're saying we can, I think I know where you're going. You're saying we can come back?
Yeah, we can definitely come back. We can write our policy or our rules to say, hey, after a certain amount of time that this violation's been removed, I want you to move those flows back over. But let's say you don't want to do that. You have the availability to keep the flows on the current path because again, moving that traffic back and forth, maybe that's what's causing that jitter. It's like too much traffic, so maybe you just want to keep them where they're at. Or again, you can move all those flows back over because again, you're paying for that pip circuit. You want to use your pip circuit. So flexibility for the admin of that site.
Okay, let me throw a real big curveball. What if we leave or we write our policy, or can you write a policy that I'm going to keep the 4 calls going over here in this yellow link, that yellow tunnel, but I get a 5th call or a 6th call or something. Can I say, hey, let's try this red link again?
Yep. Yeah, we could do that. So you can write policy to keep those flows there. And then since the violation's been removed, the next flow that comes through would use the red link for NPL.
Man, that's just, okay, that puts the I in intelligence for me right there. That kind of cinches it. So I kind of get this where this is, networking 2.0 here. We've been in 1.0 for a few decades, since the 60s. And this is just, this blows my mind. This is really cool. Wow. Yeah. Okay. So let's drive down a little bit more, because there's one question I asked you a while back, and I think you gave me an answer which kind of blew my mind. Let's take the jitter, latency, packet loss, and voice stuff out of it. Let's say that we are using Office 365. And not only are we using Office 365, but we're using different workloads in Office 365. How, we all know, I think the folks watching this kind of know how we can discover what voice is. Right. I mean, there's some well-known ports. There's some things like classification. Anyway, there's some things that we know about voice, and we can identify it pretty easily. Office 365, if I recall correctly, what you told me was, not only can you identify Office 365, but you can identify workloads inside Office 365, like distinguish between OneDrive and vStream, or OneDrive and Word Online, or something like that. Tell me a little bit about that, and how do we do that?
Right. So with SDWan, we're using deep packet inspection. So I'll refer to it as DPI from now on. And what DPI, that's going to do.
Hold on, you're throwing some acronyms out that we probably need to define. Okay. So deep packet inspection, when you say that, I think of NBAR.
Right. Very similar to NBAR.
Okay. So let me explain NBAR, and tell me if I have it right. NBAR, let me see if I remember, network-based application recognition. And this was a Cisco feature that came out back in the day, and you would turn it on in routers, and what it was able to do, just based on port numbers, like DNS is 53 and FTP is 21 and Telnet's 23, and it would identify by destination ports where or what type of traffic this was. And once it said, okay, this is this and this and this, it could classify those, and then we could put some policy on that and say, oh, this one I want in a high queue, and this one I want in a low queue, this one throw it away, whatever. So how does NBAR relate to DPI, or is it related at all?
So I like to think of it as it's NBAR on steroids. We can go a little bit deeper. Like Cisco is still going to be using NBAR, like their 2.0 version. So it's just the next generation NBAR. And then the other vendors have their own engines that are doing to when that packet goes across, they're waiting for the TCP transaction to happen. And they can look at to see, like you mentioned, the source and destination ports, but we can also look at source and destination IP addresses. Because like you mentioned, Office 365, those are well-known public IP addresses that we know that we need to get to Office 365. We can also look at the IP protocol. And if it's not in this library, it's something you can add too. We can custom build applications just for these customers now.
I see. So 1.0 of this DPI or Cisco's NBAR was looking at source and destination ports. And now that we have all these cloud services, all this SaaS stuff out there, there's IP addresses that are identified for these particular workloads, whether it be OneDrive inside Office 365 or EC2 machines inside AWS. Those are well-known IP addresses. That's what you're telling me. And then they are in databases inside these features inside these boxes now.
Exactly.
Interesting. Okay, I got that. And now we can do more NBAR 2.0. Got it.
Yeah. So like you were kind of mentioning too, like if we have, we could have Office 365 traffic, but you mentioned like if it's Outlook traffic, we can identify that. We can see if it's, if it's a spreadsheet being uploaded to the cloud, is it shared SharePoint or share?
Yeah.
OneDrive.
That's deep.
Yeah,
no pun
we're going pretty deep. Yeah, but
deep packet inspection. I got it. That's that.
You can control because like Skype, like you want to maybe prioritize your Skype video traffic because that's going to have an impact on the user. But an email maybe not as imperative to get across the MPLS link as it is. We could say go over INET because it'll get there when it gets there sometimes.
Yeah. I got it. So this makes perfect sense to me. Okay. So okay, then deep packet inspection, and I'm sure where you're going after that is traffic steering.
Traffic steering, yes. So we kind of mentioned again, like we've already looked at how we can use our voice. We want to prioritize that to use MPLS, but with these two paths that we have here, let's say, like you mentioned, I think at the very beginning of this session, that you have a centralized firewall, right?
Mm-hmm. Yeah.
You're going out to the internet, and so all this web traffic from branch 1 and branch 2 to get out, it needs to go through the data center. Well, we don't really want to just use our internet path. That's kind of a bad use of our resources. So we could actually say Office 365 traffic. We'll generalize this for us. We say load share. So we can say one session go over MPLS, one session go over INET. So we're using both our paths to get to the data center, and then that data center will forward it out to the firewall. But not only that, let's walk through a flow really quick.
Okay.
I know you know all about asymmetrical routing and how that's a huge headache, right?
Oh yeah, I mean that's packet order. We did some, we didn't want that before. Right. I mean, we wouldn't want that.
So let's say this green line right here is a Office 365 flow. So he's going to go through our data center, and he took that red path. Goes out to the firewall.
We want to go through our firewall because we can put policy there and do NAT traversal and all that cool stuff.
Right. So he hit the firewall, went out to the Office 365 cloud, came back, coming back through our firewall. But let's say when he comes back to the data center now, we have forward and reverse latency and same for jitter and all these other measurements. So maybe like the return latency is better over INET. Maybe that's going to be the preferred path. So we could actually send this session back down this way. Sorry, let me wrong direction.
Yeah, I see where you're going. You meant to. I see exactly what you're. Let me see where this next line is going to go.
We're going to go this way. So it's asymmetrical.
Wow.
But because it's tunnels and it's part of the overlay, we just see it as coming back from that LAN segment.
So we're taking one path. So you're really using, okay, I got to back up here, put it in reverse. In the old days, if we would do what we would call internet breakout, local internet breakout, which is this branch site number 1, and I'm going to take my purple pen over here, is branch site number 1 right here. Any internet traffic, we wanted to probably go out, the internet, because Office 365 is on the internet. But you're saying we can go over MPLS and now use both of these paths in an asymmetrical way so we can increase performance. Wow, that's real path intelligence. So that speaks to path intelligence and traffic steering of applications. Interesting. Okay, let me throw some more intelligence at you. Could you break that out and say, okay, I want this particular scenario. when my users are using Word Online.
Of course. Yeah.
And then I want another scenario, maybe MPLS only over there to the firewall if we're loading a OneDrive document, because I got a lot of security and stuff in my firewall, and maybe I have some DLP or something going on there, data loss protection, and I want to look inside that document, or I have some mechanism there that's looking inside these things to make sure, I don't know, we're not giving out, Project X documentation to anyone outside our firewall or something like that. Can you do that?
Yeah, we could do that. We can break out, again, I generalized the Office 365 traffic, but we could start breaking it out to look at, a Word document.
Granular. Wow.
Yeah, we could do like, share the one share drive.
Interesting. So this is bringing it together for me, definitely. So, okay, we've talked about transport and hardware independence. We've talked about path intelligence. We've talked about traffic steering. This is just wild stuff here. And then provide visibility of applications rather than ports and protocols. I think we covered that as well with the NBAR and DPI stuff.
Right. I guess one thing I probably would add here is, even though if we don't write a policy for it, it doesn't mean that this box isn't identifying that traffic. From a user perspective, just like your NBAR, like you used to, we could go through and see what's the top applications that are being used, so we can maybe start writing some better rules for it. So it's identifying all the sessions that are going across.
So you can gather all these analytics with this new way of SDWan stuff, whatever software you're using, and then start being more intelligent about your policy.
Exactly.
That brings up something that I'm gonna talk about here in a second, the IBM QoS story. But first, let me tell you this. I was reviewing some training the other day, and they were talking about Netflix being a business critical application. And what it was a hospital that wanted to categorize Netflix as a business critical video streaming service for its customers. Now that blew my mind. I was like, what in the world? Is Game of Thrones now business critical? But it is now. Where traditionally we would aim to stop all this stuff, now they talk about being part of their branding and having patients and patients' families consuming video while they're waiting to provide a better customer experience, because they want those return customers. They want people to feel comfortable, welcome, and a good experience in the hospital. So they're prioritizing things like Netflix. And I guess with all this stuff you laid out, could we do that as well? I guess you could write policy that at branch one, what?
So the takeaway here, again, with some of these vendors, there's already over 3,000 apps identified. So if you went through there, you could see YouTube HD, Netflix, and these other streaming services like that you're mentioning that are important to this business. So we could go through and grab those. Maybe it's, like I said, maybe it's not just Netflix. Maybe you want to have YouTube in there too, because that's all kids watch now. They don't watch TV. And we could build that policy and say, hey, the YouTube traffic needs to take MPLS, or we could say it needs to be load shared over iNet.
Load shared, yeah. So you're gonna, Now that makes perfect sense to me. Now, just looking at the drawing now, you would use the breakout. I want to draw some stuff again. Let's say Netflix. I'm gonna do red for Netflix, right? So there's a Netflix user out here, and you're saying that this is kind of business critical now. So you can write policy that we're going to utilize some links here. So we're going to go this way. And then as this thing gets filled up, we're going to make sure our customers out here being able to go to Netflix, and it's going to go this way. And Netflix is out here on the internet land, on the Indosphere. So now we can take advantage of several links. And I guess you could even expand that. And let me make another. Oh, I'm going to get fancy here. I'm going with blue. We can even have more Netflix going this way.
Right.
Wow. I mean, this in the past would just be and over-engineered. I mean, just 2 years ago, 3 years ago,
Be a
it
headache.
would be who would engineer something like this? It would just be like, no, absolutely not. You can't do this. This is way too complex. There maybe have been some things with per hop behaviors and all. I mean, if you could figure this out, just 5 years ago, that would just be crazy. So you're saying now with SD-WAN, if I hear you right, and these four topics we talked about, this is easy peasy.
Easy peasy.
Wow.
We try to
Okay.
make we try to make it easy.
Try to make it easy. Okay. So let me go back to this IBM story. So years ago, this is probably 10, I'm dating myself, 15 years ago, we used to work closely with IBM for policy. So you're talking policy. That's what we used to do. I used to work for a company, and all we did was go in and consult with customers. We'd go in and say, okay, let me look at your WAN. Here's your big WAN. You got thousands of routers. And we'd bring all the line of business people in, and they were using all different applications that were usually at the data center. And then we would put all these applications on this whiteboard. I mean, the whiteboard was stretched from, corner to corner on the from one wall to the next wall. And after we had all these applications listed out, then below that we would say, okay, this is transactional, this is FTP, this is high priority, this is low priority. And then after all that, we would assign these characteristics, DSCP values, disassert code points. Just for the folks, it's just a way to IP marking on each packet for each of these things, so we could prioritize them in all these routers the right way. But we would, put these DSCP values on all these applications. And man, I tell you what, it was dress right dress. We'd come out of there very proud with our heads held high, our chests out, beating our chests, because we figured all this out and we wrote a policy. We knew every application in these big industries. I mean, these were hospitals, financial companies. And then after this, we would have our marching orders. Let's hire a slew of CCIEs, and we're going to give them this policy and go program all these switches and routers throughout this customer's network. And in theory, it was awesome. When we had it all on the board and we looked at it, said, we did it. Let's hire all the CCIs and go do it. I tell you, it wouldn't be 2 weeks after that, these CCIs would be putting these things in routers and things would change. Some other application would pop up, or we didn't know this application was going to go away. So we wanted to make sure it wasn't prioritized, and we wanted to change the policy. What say you on that? How does SD-WAN not, how does it lend itself to those things that we thought we were doing good in the past, but really couldn't execute? We really couldn't execute that.
Exactly. Well, so you see this box over here I just circled? We haven't really talked
you hadn't talked about that box yet.
Right. Well, he's going to save you a lot of time, a lot of headache, and he would have made that problem from 15 years ago. You could have implemented your policy in truly 2 weeks and been ready to do the next policy that the customer asked you for. I know we haven't talked about him, but he's a whole video in himself, to be honest. So I think we should probably save him for last time, and I'll make this story of this huge headache that you have. I'll alleviate it for you and show you how we can save the world.
Boil the ocean.
Yeah.
Great. So that kind of tees up, I guess. So we're going to do a part 2 to this and really talk about that. And you're going to tell me, I guess, how we can do that in 2 weeks. That would be bizarre to me, because I think there's people still today that do exactly what we did with IBM and still try to execute this on all the routers. And 2 weeks later, they say, everything's changed. Bring everybody back in, and we can't, and they're not even through rolling it out yet, through 10%, and something's changed, and they got to bring everything in, or it gets executed, and it does get complete, but again, everything's changed, so all the policies need to change, and all the queues and characteristics and serve code point values and all that stuff. Well, Casey, any last words?
it was a really good deep dive. I know we talked about like just 4 topics here, but we could probably spend an hour on each one and walk through use cases. So I hope this was helpful for you. And I think really the next video too, talking about that controller, I think that will really open your eye to like how we can configure our network so quickly now.
Great. Well, awesome. It was definitely helpful to me. Hopefully the folks got some good stuff out of it, and we'd like to definitely thank them for watching, and we'll see you next time on SDWan Part 2.